Have you seen sine, cosine, and tangent on your calculators? What is the value of sine 30 or sine 30 degrees? How about cosine of pi or tangent of pi? Can we identify those values without using a calculator? We will find out in this video. This is RJ, your teacher, to teach you fat math so that your brains will be fat. Enjoy learning! Circular functions. So each angle in a unit circle has a corresponding terminal side, and this terminal side has an intersection with the unit circle, and we call that the terminal point. So this terminal point has coordinates x, y, and from this we will define our 6 trigonometric functions. These are the sine of the angle, or sine theta equals y. And you can verify this if you can remember your trigonometric ratios, that the sine of the angle is the opposite side over the hypotenuse. So the opposite side here of this right triangle measures y, and then the hypotenuse is 1, so that's y over 1, or simply y. The cosine of the angle is x, so that is also same with your trigonometric ratios, that the cosine of the angle is adjacent side over the hypotenuse, which is 1. The hypotenuse here corresponds with the radius of the unit circle, which is 1 unit. So the cosine of the angle theta is x over 1, or simply x. Same with tangent. Tangent is opposite side over the adjacent side, so that's y over x. For the cosecant of the angle, that's 1 over y. For the secant of the angle theta, that's 1 over x. And finally, for the cotangent of the angle theta, that is x over y. So remember that these are definitions, so you have to remember this. So in the succeeding slides, we will apply these formulas, or shall I say definitions. So remember, the sine of the angle is y, the cosine of the angle is x, tangent of the angle is y over x, cosecant of the angle is 1 over y, secant of the angle is 1 over x, and cotangent of the angle is x over y. So the challenge here is you have to identify the values of x and y. You have to identify the coordinates of the terminal point. For example, you're asked to find the value of sine 30 degrees, cosine 30 degrees, tangent 30 degrees, cosecant 30 degrees, secant 30 degrees, and cotangent 30 degrees. So we need to identify the terminal point of 30 degrees. So 30 degrees is an angle whose terminal side and terminal point are on the first quadrant. So here, this is the terminal point of 30 degrees. So we need to identify the coordinates of that. So that is the terminal point, and if you will drop an altitude for that and create a right triangle, the triangle that you will be forming is a 30, 60, 90 triangle. And the hypotenuse of that is 1, so that because that is the radius of the unit circle. So if you can still remember, the hypotenuse of the 30, 60, 90 triangle is twice the shorter leg. So the shorter leg is half of the hypotenuse. So half of 1 is 1/2. And then the longer leg is square root of 3 times the shorter leg. So this part here is 1/2 square root of 3. Or that is square root of 3 over 2. So the x here is square root of 3 over 2 and the y here is 1/2. So you can already identify the coordinates. So the coordinates is for x square root of 3 over 2 and for y that is 1/2. So after finding the x and the y for the terminal point, we can already answer all of these following these definitions. So for the sine of theta, so there, x is square root of 3 over 2, y is 1/2. So sine of 30 degrees is y. So that is simply 1/2 because y is 1/2. For the cosine of 30 degrees, that is x, and x is square root of 3 over 2, so that is simply the answer. Very easy. Third, we have tangent of 30 degrees. So tangent is y over x. So our y is 1/2, our x is square root of 3 over 2, so that's 1/2 over square root of 3 over 2. And then if we are dividing fractions, we copy the dividend and multiply it by the reciprocal or the multiplicative inverse of the denominator here or of the divisor. And then we can cancel 2 here and we are left with 1 over square root of 3. And then your lesson when you were in grade 8 for radicals, radicals should only be in the numerator. So we will multiply both the numerator and denominator by square root of 3 so that we will have the radical only on the numerator. So 1 times square root of 3 is square root of 3, while square root of 3 times square root of 3 is 3. So our final answer here is square root of 3 over 3. How about for the cosecant of 30 degrees? So cosecant is 1 over y, so that is 1 over 1/2. So 1 divided by 1/2 is the same as 1 times the reciprocal of 1/2, which is 2. So the final answer here is 2. So the cosecant of 30 degrees is 2. Letter E. Secant of 30 degrees. So secant here is 1 over x. So 1 over square root of 3 over 2. Or that is 1 times the reciprocal of this. That's 2 over square root of 3. So that is 2 over square root of 3. And then again, radical should be on the numerator. So multiply both the numerator and denominator by square root of 3 over by square root of 3. And then 2 times square root of 3 is 2 square root of 3. And square root of 3 times square root of 3 is 3. So the secant of 30 degrees is 2 square root of 3 over 3. And lastly, for the cotangent of 30 degrees, we have x over y. And x is square root of 3 over 2 over y, which is 1/2. So that is square root of 3 over 2 times the reciprocal of 1/2, 2. And then we can cancel this, 2 and 2 here. And we will have square root of 3. So the cotangent of 30 degrees is square root of 3. So as what you can see here in the example, we don't need to use a calculator to identify the exact values of these circular functions because these are special angles. So special angles are those that are multiples of 30 and 45 degrees. Multiples of pi over 6 and pi over 4. Another example. This time, we will find the 6 trigonometric functions for theta equals 120 degrees. So 120 degrees is an angle whose terminal side is on the second quadrant. So what is the terminal point of that angle, or of that terminal side? So if we can form here a 30, 60, 90 triangle again. So the hypotenuse is again 1, so the longer leg is, the shorter leg is 1/2, and the longer leg is square root of 3 over 2. But then, since this is on the second quadrant, your x here is negative. We are talking about the length here for 1/2, so 1/2 units to the left of 0 is negative 1/2. And then square root of 3 units above 0, that's square root of 3 over 2. So our x here is negative 1/2, and our y is square root of 3 over 2. Since we already know our x and y, we can already identify the 6 trigonometric functions of 120 degrees. So x is negative 1/2, y is square root of 3 over 2. So sine of 120 degrees is simply the y, so y is square root of 3 over 2. The cosine of 120 degrees is x, so that's simply negative 1/2. Tangent of 120 degrees is y over x, so y square root of 3 over 2 over x negative 1/2. And then we can have this as square root of 3 over 2 times the reciprocal of negative 1/2, that's negative 2. So we can cancel this, 2 and 2, and we will be left with negative square root of 3. So the tangent of 120 degrees is negative square root of 3. How about the three others? Cosecant of 120 degrees, so that's 1 over y. So that's 1 over square root of 3 over 2. So that is the same as 1 times the reciprocal of this, that is 2 square root of 3. And then 1 times 2 is 2 over square root of 3. And then rationalize the denominator by multiplying square root of 3 to both the numerator and denominator. So you will have for the numerator 2 square root of 3, and for the denominator, that's square root of 9, or simply 3. So the cosecant of 120 degrees is 2 square root of 3 over 3. For the secant of 120 degrees, so secant is 1 over x, so that's 1 over negative 1/2. So that's 1 times the reciprocal of negative 1/2, that's negative 2, so that's negative 2. And finally, for the cotangent of 120 degrees, cotangent is x over y. So x is negative 1/2, y is square root of 3 over 2, so you will have negative 1/2 times 2 over square root of 3. You can cancel 2 here. You will have negative 1 over square root of 3, and then rationalize the denominator. Multiply by square root of 3 over square root of 3. You will get negative square root of 3 over 3. So that is the value of the cotangent of 120. So here, you don't need to use a calculator to find the exact value of the 6 trigonometric functions of special angles. So far, our examples are multiples of 30. So in general, the values or the coordinates are just 1/2 and the square root of 3 over 2. It's either one is x or the other one is y. And then their signs just depend on where the terminal point is. So if the terminal point is on the first quadrant, both x and y are positive, And if in the second quadrant, both x is negative, y is positive. On the third quadrant, both are negative. And on the fourth quadrant, x is positive while y is negative. So here are the special angles that are multiples of 30 and their corresponding terminal points. So for 30 degrees, that is square root of 3 over 2, 1/2. For 60 degrees, 1/2 square root of 3 over 2. So as what you can notice here, it's just all square root of 3 over 2 and 1/2. So here, both positive. Here, negative and positive. Here, both negative. And here, positive and negative. So here are the terminal points, the coordinates of the terminal points. For 120 degrees, this one. For 150, for 210, for 240, for 300, and for 330. Okay? So 90, 180, 270, and 360 are also multiples of 30, but I skipped that so that you can see easily. We will have another slide for that. Or in radians, so this is pi over 6, 30 degrees, pi over 3, 60, 120, 2 pi over 3, 150, 5 pi over 6, and so on. So for 7 pi over 6, 4 pi over 3, 5 pi over 3, 11 pi over 6. Okay, so these are the terminal points. Okay, so this is the x that you're going to use and the y. Here, the x and the y, the x and the y. Okay, let's have other examples. This time, it's multiple of pi over 4. Okay, so here our angle is negative pi over 4. So since this is a negative angle, we will move in a clockwise direction from the positive x-axis. So pi over 4 is that, or that is simply negative 45 degrees. So that's the terminal point. And what are the coordinates of the terminal point? So we have to remember the properties of a 45, 45, 90 triangle, that if you know the legs, the hypotenuse is square root of 2 times the leg. But this one, the given is the hypotenuse. So the hypotenuse, to get the leg, divide this by square root of 2. So 1 divided by square root of 2 can be simplified to square root of 2 over 2. So the x here is square root of 2 over 2, and the y is the same. Okay, I mean the length of this is square root of 2 over 2. So square root of 2 over 2 units from 0 going down, it's negative square root of 2 over 2. So the coordinates are square root of 2 over 2, negative 2 square root, negative square root of 2 over 2. So this is the x, and this is the y. So x is square root of 2 over 2, and y is negative square root of 2 over 2. Okay, let's now solve or find the values of the 6 trigonometric functions of the angle negative pi over 4. For sine, it's just the y, and y is negative square root of 2 over 2. So that's it. For the cosine, it's the x. So the x is this one, square root of 2 over 2. For the tangent, that's negative, that's y over x. So y over x. So negative square root of 2 over 2 over square root of 2 over 2. So they're just the same. Negative divided by positive, it's negative. So negative 1. Okay? Why is that so? This is square root of 2 over 2. This is also square root of 2 over 2. If you divide numbers or same numbers, except 0 of course, by itself, then you get a 1. But since this is negative divided by positive, so it's negative 1. How about for the other 3? So the cosecant is 1 over y. So that's 1 over negative square root of 2 over 2. You will get 1 times the reciprocal, negative 2 over square root of 2. So that's negative 2 over square root of 2. Rationalize the denominator. So multiply by square root of 2 over 2 over square root of 2. So 2 times square root of 2 is 2 square root of 2. Square root of 2 times square root of 2 is 2. And then you can cancel here the 2. And you will get negative square root of 2 left. Secant, 1 over x. So 1 over square root of 2 over 2. So that's 1 times 2 over square root of 2. That's 2 over square root of 2 times square root of 2 over square root of 2. So 2 square root of 2 over 2, or simply square root of 2. Cotangent, x over y. So square root of 2 over 2 over negative square root of 2 over 2. So we just put it this way because we don't have space anymore. So you're dividing by the same number, they just differ in sign. So that's negative 1. So for the multiples of pi over 4, like this, and this, they're just all square root of 2 over 2, the coordinates for x and for y. If it's in the second quadrant, for 3 pi over 4, x is negative. For 5 pi over 4 on the third quadrant, both are negative. For 7 pi over 4 on the fourth quadrant, x is positive, y is negative. Or in degrees, that's 45, 135, 225, and 315. How about this? Sine of pi, cosine of pi, and so on. So we need to identify the terminal side and terminal point of pi. So pi is half a revolution, or that is simply 180 degrees. So the terminal point is here. Since this is a unit circle, this is 1 unit away from the center, which is 0, 0. So the coordinates are negative 1, 0. So x is negative 1, y is 0. So we can already identify the 6. Sine of pi is y, so that's 0. Cosine is x, so that is negative 1. Tangent is y over x, so that's 0 over negative 1. 0 divided by negative 1 is 0. Cosecant pi, so that's 1 over y, so that's 1 over 0. And dividing by 0 is not allowed. So we don't have a value for that, for 1 over 0. We call that undefined, no meaning. Secant of pi, that's 1 over x, so 1 over negative 1, negative 1. And cotangent of pi, x over y, so x negative 1 over 0, also undefined. And we have the 4 others, multiples of 90. For 90, terminal point as coordinates 0, 1. Here for 180. For 270, that's 0, negative 1. And for 0 degree or 360, that's 1, 0. X is 1, y is 0. So, upon watching the video, can we identify the values of those? Yes, because those are special angles. Special angles are multiples of 30 and 45 degrees. So if our angles are multiples of 30 and 45 degrees, we can solve the 6 trigonometric functions. But if they're not multiples of 30 degrees or of 45, like for example 20, sine of 20, we cannot manually solve that. Okay, only the multiples of pi over 6, which is 30 degrees, and the multiples of pi over 4, which is 45 degrees. So if those are the angles, then we can solve the 6 trigonometric functions of those. So thank you for watching this video. I hope you learned. And if you find it difficult and you need to spend more time on it, you can just watch again. Thank you so much, especially to my students. Thank you.